All right, we should be live. If anyone's in the chat and they want to let us know that they can hear us, it's always fun to know that everything's working well. And we can wait a minute before we get going, and I'll kind of do a event introduction, and then we'll do some introductions of the amazing people here, and then we'll get into the cool stuff.
Where's
All
that
right.
music?
we can't put on some music. Someone says I can hear. Oh, thank you, Jay. Cool. So I see there's already quite a few people in here, so let's go ahead and get started. I think first I'll just talk a little bit about what this event is, and then we'll go into introductions of the people here. So today we're going to kind of do an intro to WhyLogs. We just launched version 1, but first we're going to talk about why we made it and the problems that it solves. And then we're going to talk about specific to WhyLogs V1, all the new cool features and improvements that have come out. And then we'll go into a demo of how to use WhyLogs V1. So it'll be a hands-on demo. We'll walk through some code. It should be really fun. And then we'll talk about how it can integrate with WhyLabs AI Observatory Store. And we'll see a demo of that. And then we'll also just be around for Q&A at the end if anyone has any other questions. But feel free to ask questions in the chat as we go. If we don't get to it right away, we can get to it at the end. But yeah, I always like seeing people chat during live events. That's, to me, half the fun of being at a live event is asking questions and talking to other people. There's also a lot of links in the description. So if you're looking to stay connected, that's where our Slack channel is. That's where kind of all of our documentation is as well, if you want to browse those as we're talking. And first up, let's do introductions. So Alyssa, do you want to do a quick introduction since you'll be going first?
Sure. Hello, everyone. Good to see that we have Chicago here. So that's a nice afternoon. I hope you have your third coffee going already. I have my first. It's like a bucket of nitro cold brew. My name is Alyssa. I am the CEO and co-founder here at WhyLabs. I used to be an engineer, and part of the WhyLog story will be about some of the problems that I was solving as an engineer that inspired some of the decisions that we've made in WhyLogs. But that's the story for when I start presenting. For now, I'm just really excited to have you all here and talk about WhyLogs.
Awesome. Thank you. And then Jamie, how about you introduce yourself next?
Yeah, hi everyone. My name is Jamie Broomall. I'm a software engineer here and working on whylogs. And so, yeah, very happy to get 1.0 out the door and answer any questions people might have.
Awesome. And then Danny, you're next.
Okay, howdy y'all. My name is Danny. I'm an MLOps Architect here at WhyLabs. That means that I work with Jamie in kind of crafting the story of where we want WhyLogs to go, what kind of features and use cases we want it to support, and I'm going to be demoing the new V1 of WhyLogs.
And then last but not least, Ray.
Hi everyone, I'm Ray. I'm a customer success data scientist at WhyLabs, so I get the best of both worlds, working directly with customers and getting to dive into the technical details. I'm coming from Salesforce previously, and I'm obsessed with machine learning.
I think we are all a little obsessed with machine learning here. Awesome. All right, Alyssa, so you're up first presenting on kind of an intro to WhyLogs and why we made it and how you came up with the idea.
All right. I cannot claim credit for the idea, but I can take you through some of the aspects of how this came together. So, yeah, like I said, today I'm the CEO at WhyLabs, which basically means that I build a lot of slides and send a lot of emails. So we're kicking off with my slides, which are very meticulously put together. And the first one is literally kind of a picture of me back in the day when I was working in the machine learning team at Amazon, deploying some of the ML applications to production. I started working in a kind of applied R&D team back in 2012. The first big application I deployed to production was a forecasting system which forecasted for 800 million SKUs at Amazon, a quarter of all Amazon inventory. We did that We generated a forecast on a daily basis, 365 days out. And the first time we deployed the system, I made a bet with the scientists on my team that I can survive the on-call for a month by myself, because it felt really, really scary. And nobody wanted to do it. But I come from kind of SRE background prior to the ML team that I was in. So I made the bet, went on call, and the picture on the right of somebody drinking out of the fire hose was really literally me trying to figure out why things are failing. So long story short, a lot of problems were happening, and when you're running something in production in the real world environment, it's not controlled. In the experimentation environment, everything is controlled. In production, you do not have any control at all, and a lot of the problems, as it turned out, come from the very complex environments that we end up building, because we need to process a lot of data. We need to process it fast. Data is coming from all kinds of places. And most importantly, data can be very, very scary. So in experimentation, we're working with these really cute, clean, tidy data sets. And then when we put this beautiful ML application to production, it faces the real world, and the real world is scary, like literally. So when we started seeing these issues back in the day when I was at Amazon, we started coming up with ways to identify when the scary real world data is breaking things in our system. And the traditional way of identifying, detecting changes, and identifying when bad things are happening to your software system is to start monitoring. So we started brainstorming how to build monitoring for production systems. And back at Amazon, we built something that was fairly custom to the Amazon set of problems. And when I left Amazon, and WhyLabs was just in the very early embryo stages of what it is now, we sat down with a handful of people and just kind of drafted. Probably on the whiteboard, it didn't look nearly as good because I could never put together such a nice looking diagram. But we drafted kind of what does it mean to monitor an ML lifecycle. And really what it boils down to is you're detecting changes in the system. These changes can be detected by capturing some kind of telemetry or some kind of signal from various stages of the life cycle. And then once you detected a change, you need to bring humans in the loop to help you identify whether this change is a really bad one that you need to jump in on and retrain the model, or pull an end on cord, or do something very drastic, or whether this change just warrants some kind of model improvement or data improvement. So it all boils down to essentially solving three problems: gathering some kind of vitals from your ML lifecycle, detecting changes in these vitals, and then communicating these changes to humans. So it seems pretty simple. When we started developing it, the monitoring system, kind of what are some of the basic design requirements for the monitoring system. We had this brainstorming session, and we were like, okay, well, the most important thing is we need to figure out how to make machine learning system part of this living, breathing software organism in production that has upstream changes and downstream, and causes downstream changes. So we just need to kind of keep track of the state of this ML application. We need to understand what changes in the upstream can cause a change in behavior in your ML system, and then how does it impact downstream when some aspects of the behavior change. So again, pretty simple. And then we went and we talked to data scientists, and data scientists were like, well, actually, we have all these different types of models, so it's not just as simple as detecting, well, it could be very difficult because we need to detect certain types of changes in deep learning models, then different kinds of changes in our decision tree models, and we have all these explainability patterns. And then they started talking about the different data types that they use. And also everybody seemed to have a very different platform, or 2 or 3 or 412 in one company, because everybody likes to build their own little platform. So they added a whole bunch of other requirements. And then we went and talked to managers of data science teams, and they were like, well, actually, what we're struggling with is latency. So we need this feedback to be really, really fast. We need to know very fast when changes are occurring in our system so we can react. And also, we're having trouble with scale because we're processing a lot of data. And of course, we worry about how much things are going to cost. Wow. So we were sitting there kind of debating whether we should even bother talking to any more people because it's getting very, very complicated as far as requirements go. But then kind of as the last step, we also talked to the ops teams. And of course, the ops teams typically worry about two things, automation and maintenance. How do you automate as much as possible of this process? Because nobody wants to do this manually. And of course, how do you maintain it over time and whose plate is it going to be on? So building an ML monitoring system has a lot of requirements from a lot of different stakeholders. And really the efforts that we did with whylogs boils down to taking some of the common patterns, foundational patterns that are needed for a monitoring system and extracting them into some kind of smart design. So we took those 489,000 requirements and we boiled them down to a handful of design principles that really came from DevOps application performance monitoring systems, because those at the time when we were building whylogs, those were probably the most established design patterns we can look at. ML monitoring as a thing didn't exist yet. So we kind of started outlining on the whiteboard various things that we need to capture in order to enable monitoring. And a lot of things kind of boil down to the fact that you need to gather telemetry. You need to figure out what are those vitals of your system, because if you're watching the vitals, you can watch them for change, but what exactly are the vitals and what are their properties? Again, that list of various design decisions was getting very, very long. When we kind of exhaustively put it together, we noticed that kind of this telemetry piece is super important, and it is pretty generic. Like building a solution that gathers telemetry from an ML and data system generalizes pretty well across all of these design or all these design requirements that we've gathered from conversations with data scientists and managers and ops people. So then we sat down and we're like, okay, so telemetry is very important. We need to figure out various vital signs that have to be captured from the system. Like, can we enumerate them? Can we like exhaustively figure out all of these metrics that we need to capture? And turned out that it's incredibly hard, because if you can sit down and exhaustively list all of the metrics that you need to capture, then you would only be capturing the things that you know can go wrong. And that would mean that you are not capturing or will never have access to the things that that you don't know could go wrong. So that's basically this little cute meme here. To me, that's what observability is all about. And I've talked to charity majors a handful of times and have read all of their amazing thought leadership work on the concept of observability as it applies to monitoring. And it's really, really hard to kind of wrap your brain around. But what's important is to understand that if you're trying to enable monitoring or observability, you can't just exhaustively enumerate all of the things to monitor, because then you're going to have a lot of blind spots. So, okay, if we can't exhaustively enumerate all of the things that we need to monitor, what do? Well, we kind of go back to a little bit more open-ended concept of what's being captured, and we call that concept logs. So logs, essentially, they capture a lot of the statistical properties of everything that's happening in your system over some kind of batch of time, and then you can use them to boil them down into particular metrics, and you can kind of explore the various data in your log files to find those unknown unknowns. So essentially, it's kind of a cute way of saying you just capture everything you could possibly capture, and that everything boils down to these kind of six things that come in to be very important. So you capture your lineage metadata, you capture schema, you capture all of your counts, you capture summary statistics as exhaustively as possible, distributions, and stratified samples. So when you start capturing these things, well, the first thing that you would face is that there's a lot of implementation detail, and it gets very, very annoying to kind of implement capturing all of these things. So what we did with whylogs is essentially we implemented it for you in a very, very generic, generalizable way, and we put it into the open source, because the more conversations we had about this concept of data logging, the more we learned that it is fairly foundational, and it has to be very, very customizable, but there is a set of things that do not change from use case to use case. So we put the set of things into whylogs, open sourced it, and now we're getting a lot of feedback from the community to expand what we're capturing, how we're capturing, and hopefully as we keep going, this would be further established as the standard for data logging, and you will never have to worry about capturing about what needs to be logged and how is it being logged and so on. You just plug in the library, just like statsd, and it logs everything that you need. So that's whylogs. And really quick, whylogs implements a few fairly important things that are key to being able to monitor a machine learning system. The first thing that it implements is a way to profile or kind of capture the logs and the vitals of your system across different points. So here specifically in this example, you're capturing profiles from training and production. That's very critical because what happens in training becomes your baseline, so you can check your production against that baseline. That's one very key property. Another very key property of whylogs is the fact that it captures things, the profiles that it captures are mergeable. And this is absolutely key because essentially your data comes in these mini batches. It could be, mini batches could come from a distributed system or a real-time system. And what you want to do is you want to organize all of these mini batches that are pretty sporadic into something meaningful. And meaningful is organized in the meaningful time frame. So you want to merge the mini batches into hourly profiles, for example, so you can do intraday patterns when you're monitoring, or you want to merge them into weekly, daily profiles or weekly profiles. And this is absolutely critical because when you're monitoring a system and you find some kind of problem, you want to pinpoint when the problem began to ideally, a minute, but will take an hour even. Then if you can pinpoint it, you can look at, okay, how did my data change within this hour? What were some of the system changes that were happening? And this really allows you to debug your machine learning system the same way you would debug the software system. And then another very, very critical aspect of whylogs that again comes from the fact that they're mergeable is the fact that they're comparable. So when you take one single profile, it just captures all of the information over a batch or a mini batch of your data. Then when you have two profiles, so imagine you have a profile from training and then a profile from yesterday's inference run, you can compare two profiles and you can start doing unit testing. So you can extract constraints from the training data profile, and then you could apply those constraints on your inference data to see whether your data is still intact. And then when you have three or more and you're continuously building out these profiles, you can start essentially applying much more sophisticated forecasting and anomaly detection algorithms to catch various deviations from the baseline or various deviations over time. So that's a very, very quick overview of various design decisions that we made to put together whylogs. Hopefully this was informative and sparks some ideas in kind of the blogging in the ML world. I'll close with the fact that this is a community effort. We're super excited at WhyLabs to be driving it. We're very passionate about it, but we wouldn't be able to build it without feedback that we're getting from the community. So everybody who's here at this launch party, please consider contributing, even sending us feedback is like on Slack or just email me is already super valuable. We are always on the lookout for this feedback and incorporate it very proactively into the library.
Awesome.
Right.
Thank you so much. Does anyone have any questions related to what Alessya just talked about? I see someone said micro batches for the win. So someone's excited about micro batches.
Yeah, why? What about micro batches exciting? I'm excited about micro batches, but I'm a nerd.
Someone else also said they love the name.
whylogs.
Cool. If there aren't any other questions, and you can definitely continue to ask questions, but we're going to move on. Jamie is going to quickly present on some of the new features that came out in whylogs v1, and then we're going to get into the hands-on demo. Jamie, you're up.
Yeah, thanks for that great introduction, Alessya. I was thinking back to the scenario you described when you're working on the ML forecasting, and I had the opportunity to work on some of those early systems. And one of our colleagues made the comment that if you could fit your data on a laptop, it's not big data. And even though we were running on a cluster at the time, you could theoretically adapt some of our algorithms and done it faster. And I, since then, have been thinking about like, well, what is different? What are the kinds of algorithms that you actually need for big data? And this idea of summarizing, gathering telemetry, resonated with me then. That's when I first learned about Apache data sketches, or just data sketching in general. And I've been thinking about that probably for the last 6 or 7 years. And so it's a really pleasure to get to work on this and focus on that kind of tool. So I'll go a little bit into that, but I just wanted to work back from how we structured the changes in whylogs v1. And the two things we wanted to do is walk backwards from a simple API. We said a lot of the feedback we're getting from users in the community was, we like the value proposition, we get the product, we need this tool, but it's not always easy to use. And then another one was just about making it faster, so that if you injected the gathering of telemetry, you could scale to very large amounts of data, and you wouldn't notice it latency-wise too much if you were in a real-time production system. So these are the kind of 5 areas I'll cover here briefly, is just talk about some of the API simplifications we have in whylogs v1. Profiling constraints is a nice way of doing some data quality checks on your data, and we can talk a little bit about that. The profile visualizer is also important to just showcasing the value of a whylogs data profile, so that as a data scientist or someone that's just exploring data and you're just checking out whylogs, what do you do with that profile after you get it? And so this shows just like you can visualize distributions on your data and kind of explore the data before you even start thinking about what are the constraints or what are the kinds of things you want to monitor. Performance improvements was a very large motivation for the changes and some of the design approach we took with v1. So that's the thing that I'm probably most excited about, as well as just trying to make it easier to use is really important. So investing in the documentation and making our examples a little bit more rich is another area that we invested in with this push for a new version 1. So the old API, this is what we call like our introductory example. Like, what's the simplest way you can create a whylogs profile and get started? And it's not too bad. You know, we have this helper method to create a session for you. But we felt that it was just like a little bit too much conceptually to overload a user when you're first learning a tool. And so before we even implemented anything, we wrote this right-hand side, just said like, what do we think is the minimal things that a customer or user in the community who's wanting to gather these telemetry on their data would have to do? And so we rallied around like pandas as being a pretty common format, but we can use any kind of data here. We work really well with the data frames from pandas and some other, we'll talk about some other shapes there. But this y.log is the main thing, and it returns a result set which contains profiles which you can analyze or send to S3 or to WhyLabs if you want to take advantage of the WhyLabs monitoring. But this is what we worked back from. We said, this is what we think the API should start out as. And from that, we found out there needed to be a lot of design changes, and so somehow how we implemented it. And while I think the version 1 has a lot of complexity behind the implementation, the API is trying to be very focused on this simple scenario. So as mentioned earlier, constraints are a way to define like expectations on your data or rules that you want to be able to validate new input from. We think that this is one way of just exploring what a profile can give you after profiling with whylogs. So you get some maybe distributions on numerical data. You'll get frequent items on categorical data if you have labels. And then you can say, like, in this example, this is from, I think, the wine data set. You could say that the quality is just this good or bad label, and that we expect that all future data sets that, or future profiles of new data should follow the same kind of pattern. You can have distributions on pH. In this case, the maximum is less than or equal to 4.5, which sounds a bit acidic to me, but maybe that's right. We had a lot of push around trying to describe various different constraints on our data. And what we decided to do was to create customization first. So we have a very simple API that lets you just define your own expression on the data. And I'll talk a little bit about that in our canonical example. It's you could pass in a function or a lambda. It doesn't really matter how you define it. But as long as you can describe expectations around the metrics that we collect, you can generate constraints on it. And the constraints operate on the profiles, just to sort of clarify that. So they're actually very fast to evaluate, even on very large data sets. The profile visualizer, I think, is the next step. Like if I'm just starting out to explore whylogs and I've gathered some initial telemetry data, like what can I do with it? And these are some of the things that we try to highlight here. You can create summary drift reports, do histogram comparison so that you can kind of visually see if there is a shift, a drift in your data. You also get some basic feature statistics out of this. The thing that I'm most excited about is the performance improvements. One of the key things we changed was trying to do less of the calculation in Python. Like we're using Apache data sketches underneath the hood, and we want to do more of that work and less iteration in Python. So I think the biggest secret sauce there is just trying to vectorize more of that computation and passing in arrays of data. So we're basically doing batch processing of all like types. So if we have a mixed types in a column, we'll batch up the integers and then pass those together to do a batch update. So if you're doing something like calculating distribution, we'll get a like KLL sketch can update on those with one call. And that's where this, I mean, it looks kind of crazy, but our old whylogs v0 would have a hard time really getting to the, like this bottom row here is a little under 100 gigabytes. And it, you know, I mean, it's a little too long to wait. So to days range, just it goes from being used like not usable to usable in this kind of scale range. And we can talk a little bit about that more if you have questions. A big usability refresh. We spent a lot of time trying to restructure how we generate documentation. The core repo itself has a lot more strict rules. We're using like typing and having MyPy involved in there, trying to make it a little bit easier to develop and generate the right kinds of documentation. I think in whylogs v0, there was a little bit of confusion sometimes around the semantics of a parameter that you pass in, and when it could take on different types and it wasn't described, made it harder for us to document as well. So we think this kind of is a natural time to invest in the documentation refresh. So I hope people will check this out. And we're actively investing in this still. So anybody has feedback, we can try to focus that effort as going forward. So it's just kind of a high level overview of the big new things. If people have questions in the follow-up, I'm happy to dig into some of the numbers more or answer any questions you might have.
Awesome. Thank you, Jamie. And yeah, let us know in the chat if you have any questions. I see someone asked if all the parameters, such as like min, max, are stored in a config file in the or defined somewhere in the WhyLabs UI.
For the constraints, so we have all of the things you can create constraints against are defined in our metrics. So it depends. So another thing that's new with whylogs v1 is it's a little bit more configurable. And we are more strict about only generating metrics that are relevant to the type. So we don't automatically try to gather an empty set of metrics for strings if you only have numerical data. So for numerical data, we have distributions, we have counts, and a few other things. But distribution gives you a lot, which gives you max, min, and then a probability mass function. So you can say the P99 should be less than this amount, or whatever quantile you want. We do have those documented. It's probably something we need to have a little more examples on, like how you use those to get and have a little bit more convenience functions around it. Because right now it's kind of a core API. Could show the canonical example of the constraints there. I think Danny wanted me to go that way, but
yeah,
maybe we'll do it at the end.
If I can jump in, actually, Michael, if you stay tuned for the next like 10 minutes, I'm going to show you exactly which metrics we can pull out just out of the box with the default, with like a nice table that shows like, here's the min, here's the max, here are these other metrics, and then you can define your constraints based on those metrics, as well as a cool future thing. So stay tuned.
Cool. And I think unless there's any other questions, I think we're ready to get into some exciting code examples, Danny, if you're ready to present on it.
I sure am. Okay, can everybody see the screen okay?
They should be able to see it now.
Okay, great. So to people who have attended talks by me before, this might be a familiar problem set that I'm going to be showing you. For those of you who have never seen this before, what I'm going to be doing here is defining a really simple data pipeline and then showing one of the use cases for whylogs, which is validating data quality in the data pipeline. So, as Alessya and as Jamie have talked about, there are a lot of different applications for whylogs. There's a lot of things that you can do with these telemetry artifacts. And data quality validation is just one of them, but it's one that I think really neatly highlights a couple of different features about whylogs. So getting into the nuts and bolts here, we're going to be looking at this open data set, the NYC taxi data set. We're going to be setting up a data pipeline based off of it. And then later in this notebook, that pipeline is going to break. First, it's going to break loudly, so it'll be really obvious what's wrong, but then it's going to break silently. And that silent break is really where whylogs comes in and is super useful. So let's start off by just defining this pipeline. We've got 3 pretty simple steps in here. Everything's just happening with pandas. We're doing a couple of feature transformations, a little bit of feature extraction. We're creating some new features. Now we can execute our pipeline, make it act on this data. We've got our end result, which is this nice deliverable that has the total amount of fares for each day broken down by borough within New York. So, this might be a deliverable that we want to give to our manager, or maybe it's going all the way up to the executive suite. This is probably informing some kind of analytical decision that's being made. So this is really more in the analytics side rather than on the machine learning side necessarily. But the things that we're going to be talking about, the data quality validation, I'll address how those are really helpful in machine learning as well. So with that in mind and kind of understanding our objective as well as the scenario that we'll be running through, let's see one of the ways that a pipeline can break. So we've defined our pipeline for February. Now we're going to dive into March. In March, we've got another data set that looks just like the previous one, but something insidious is going to happen here. So somebody is going to, because of some change in the upstream data pipeline, upstream of where we get our data, somebody has transformed what used to be an integer now into a string. And now if I run through this pipeline again, I get this very obvious break, right? It's very easy to see that I can't do a join between a string and an integer because Python retains some amount of typing. So I get this very nice loud error. Okay, so let's review what happened. I had a violation in the data contract and the data definition that was previously used. And that break in the data contract resulted in a break in my data pipeline. But in order to fix this, and importantly, in order to detect it, it's pretty easy, right? All that happened was this thing failed. I can see this very obviously in the classic logs. So I can go back and I can fix my data pipeline step in order to make sure that we're ensuring that the location ID is an integer and not a string as it was previously broken. So now we can run through this again. and we'll successfully get the output that we want, and we'll have this good deliverable to give to our boss. Okay, good. So this is a loudly broken data pipeline. This was easy to pick up on and easy to fix. Now we're going to go through a slightly different scenario, which is a silently broken data pipeline. So the same scenario happens where somebody upstream of us took the data that we are going to be ingesting and changed some definition in this data. And those of you who have worked in data engineering or data operations, or even probably a lot of analysts and data scientists in the audience, are probably familiar with this problem of the fact that by being a consumer, by being a customer of some upstream data source, you are entirely reliant on, entirely dependent on the definitions that have been established for you by the person upstream. And if you don't have, meticulous practices in place, I mean, like really just incredible top-notch practices in place to ensure that data contracts are always being validated and always being enforced, then it's really likely that at some point somebody upstream is going to make a change. You're not going to know about the change. Hopefully the change is going to cause a loud break, but it's possible that, like in this case, we're going to have a silent break. So in this situation, the total amount variable has been multiplied by 100 and transformed into an integer, whereas previously it was a decimal. A likely explanation for this is that previously the total amount column was a representation of dollars and cents, but for some reason, somebody upstream decided it would be more efficient to represent things as just cents, so they wanted to multiply everything by 100 and convert it to an integer. So now, instead of the total amount being represented in terms of dollars and cents, it's being represented only in terms of cents. Now, when we run through our data pipeline, we can see that it's not going to break, right? Like it's still a numeric column. It's still going to be able to run through all of this. And we get this deliverable, and if we're paying really close attention, maybe we'll notice that it looks a little bit odd that, there's like trailing zeros and there's not like the decimal places that we saw earlier. But, as somebody who's formerly been an analyst and formerly been a data scientist, I know that I didn't meticulously check every single deliverable before I sent it over to my boss. And this is what's really insidious about this, right? Because my pipeline ran successfully and I got my results. It's just that my results are not actually representative of the world that I thought that they represented. Because there's been this change in the data dictionary and the definition of my data, I am now misrepresenting information. And in this situation, it was pretty apparent, right? Probably my boss or like whoever my consumer is probably going to take one look at this and go like, there's no way we 100x'd our revenue in all of this. Danny, like what happened? What went wrong? But as you can imagine, there's other scenarios that are even more incipient than this, even more non-obvious, where the changes are smaller or they're stochastic rather than deterministic, or there are all of these different ways and all of these different permutations, coming back to what Alessya talked about with the fact that there are so many unknown unknowns. There are so many different insidious ways that our data can change and that we can be negatively affected by it. Again, in our scenario, probably the consumer of this data, our customer, is going to be able to quickly identify this. And the harm is really just going to be like a little bit of trust lost with them, right? Because now they're going to be a little bit more meticulous about checking our work. We've probably lost some rapport. And as those of you who deal with data know, like maintaining rapport with your customers in your data generated products is absolutely vital. But you can imagine other scenarios, like if this was being reported directly by the C-suite to the board of directors, that having misinformation like this is actually not just an issue of lack of rapport or broken trust, but actually a problem that could result in fines from regulatory bodies, could result in like a lot of really bad PR. There have been a couple of examples recently in the media where there have been problems with data quality at major companies. So as you can imagine, like this could get a lot worse than just the scenario that we're looking at here. Okay, so hopefully I painted a sufficiently gloomy and scary picture of what the world might look like. But there's a shining path and a glorious light, which is whylogs. So with whylogs, what we can do is we can take a profile, right? We can log our data and generate these data profiles. It's really important to mention that these data profiles, they are not samples, they're not like subsets of our data, they're actually summaries of the entire data set. And this is a really useful thing to keep in mind, because it's really powerful to be able to profile data instead of having, and to be able to summarize it like this, instead of having to just sample it. when you're sampling data, especially when it's not normally distributed, you end up losing a lot of fidelity in the distribution. You can imagine, if you're familiar with data distributions like power law distributions or exponential distributions, when you've got a long tail at the very end of your distribution where there's only a couple of data points, but a very significant effect from those couple of data points, the effect of sampling is to remove a ton of information about what's going on the tail. And importantly, for data scientists and data analysts, normally what's happening in the tail is actually very often the very interesting thing. So removing all of that information through sampling leads to extreme inefficiencies in your ability to do stuff like monitoring machine learning models in production or ensuring data quality or all of the other things that whylogs can be used for. So diving back into our example, we've got these profiles that we can generate. I'm going to take a profile from the first data set that we were looking at from February that we know was good. It created the report that we wanted it to. And then I'm also going to take a profile of this new data set, the one that we know is bad, but that Danny in this scenario doesn't. And I'm going to start by just visually looking for issues in them, doing some exploratory data analysis, a little bit of manual data validation. But then I'm going to circle back to those constraints that Jamie's been talking about and show how you can define constraints to do the same kind of data validation automatically. Okay, so I've generated my two profiles. I've put them in a visualization. The first thing that I can do is I can create a summary drift report. This is cool because it allows me to visually compare two profiles side by side. And as you can see, there's this p-value calculation that even runs a KS a KS test or a chi-squared test in order to validate whether the data has drifted, whether there's been a change over time in the composition or nature of this data. Now, you'll notice that it doesn't really look like there's any data drift here. And the reason for this is very simple. The distribution of data is actually the same, right? All that we did was multiply by 100. So we have the same looking histogram. It's just that the x-axis here is 100 times longer in one of them than the other, two orders of magnitude longer in one of them than the other. But the histograms still look the same. This would be really good at being able to pick up on data drift, data change that happens over time. But what we've got is actually a more insidious situation. And in order to be able to visualize it, what we'll want to do is have overlaid histograms of the two data sets. And maybe you can pick up on it here. Here it's becoming a lot more obvious that something is wrong, right? We've got our orange reference data set, and that's very easy to pick up on, right? It's very easy to see here. But where is our blue target data set? Well, as it turns out, it's compressed all the way to the left-hand side of the screen. And the reason for that, the reason that this histogram is so tiny and all the way over here is because it's 100 times smaller than this larger histogram. So visually, when we can compare them, we can see that there's something really wrong. Okay, this is a really useful clue in helping us diagnose the problem, because now we can take a look at the simple summary statistics, the features, and understand what's going on with our data set. So you can see like a percentage of distinct values. We can see our standard deviation, our min, our max, our mean. Great. We can do this for both of our data sets, both the target and the reference data set. And we can see that there is now, it's very obvious, a huge discrepancy, right? Basically, everything is multiplied by 100 for our target data set. For our reference data set. So the minimum, the maximum, the mean, even the standard deviation are all multiplied by 100. And now, through this data quality validation, through this process of visualizing this data, it can become very apparent to me as a data analyst or as a data scientist that I've had some kind of issue. And hopefully I can be proactive about doing this in such a way that I can pick up on these data quality or data drift or other issues before I hand off my deliverable to my manager or to the executives. Okay, so that's how you do this visually. And that's great when we have the time and the capacity to go through and manually check all of this. And especially like early on, it's really useful to do this when you're first running a data pipeline. But at some point you need to, move on to other projects and give a check mark to your pipeline and say that it's running well. But, in order to ensure that pipeline actually is running well, you want to have continuous validation. You want to have continuous checks. And that's really what constraints allow you to do. Now, Michael, I hope you're still here with us on the stream. You were asking about what metrics get pulled and how those metrics get pulled. So you can see that out of the box for all three of the columns in our data set, we've pulled a number of different metrics: the total count, count of null, the type, the cardinality, which is the number of unique values, information about the distribution, such as the min and the max, obviously, but also this trailing quartile range, so we can see how our quartiles are changing. All of these things come out of the box with metrics that are automatically generated on the appropriate data types in whylogs. But as Jamie talked about, another big focus with whylogs v1 is increasing the extensibility of whylogs. And that meant making it a lot easier for our users to be able to define custom metrics. So in addition to the metrics that you see out of the box here in this table, you can also define more custom metrics based on whatever features you think might be most useful to track. So these are the metrics that we're tracking here. Now, here's this API that Jamie was alluding to earlier that you can use to set the constraints on top of those metrics. So in this situation, I'm going to set a couple of really simple constraints. This is just a toy example. I'm going to take this total amount column, and I'm going to look at the distribution metric, and I'm going to pull out both the min and the max features from that distribution metric. And I always want my min to be greater than 20, just based on like historical analysis. It looks like there's never been a borough on a day where the taxis have made less than $20. And we want our max to be less than 50,000, because similarly, let's say we just did some manual analysis. Great. Now I can generate these constraints. I can build the constraint report, and I can run this constraint against the profile that we were using earlier. And I can get this output here. If I've imported the whylogs viz package, then I can make a little bit of a prettier constraint report, right? So we know that in our situation, this constraint has failed because we had an anomaly where somebody violated a data definition and there was 100 times as much money, or the data was 100 times larger than we expected it to be. So great, we've got this constraint report that shows our pass as well as our failure. This is really useful and really cool out of the box, especially in the scenarios that Alessya was alluding to as being kind of known known and known unknown scenarios. But what about for unknown unknowns? And this is a feature that I'm really excited to be introducing to everybody. This isn't available in the whylogs v1.0.0, but it'll be coming out in the next couple of releases. And that is this ability to automatically generate constraints based only on an input profile. So I can take this input profile 2, and rather than having to manually define that the borough should always be a string, there should be this number of unique values in it, it should always have this minimum, or it should always have this mean. Instead, I can just run this through the constraint generator, automatically generate constraints, and then run all of my future profiles through these constraints and on this constraint report. As you can imagine, this is really powerful because it, one, decreases the amount of work that you have to do, and two, it catches these unknown scenarios. Like, okay, maybe you knew that you wanted to check the total amount, but maybe you never even thought about the fact that, oh, I've got my boroughs defined, I should make sure that they're always strings. So that's the demo. Are there any questions about the demo or about the code or the API for whylogs v1?
And I see Michael is still here, and he said, awesome, clap hands. So I think he answered his question.
That's great.
And we'll wait a few seconds because I think there's a little bit of a delay between streaming here to YouTube. So does anyone have any questions?
Sage, do you have any questions in the meantime?
Someone asked, how large can the profiles be?
Oh, this is a great question and something that we probably haven't addressed enough in this session. So one of the really cool things about how whylogs works is that it's mergeable. And that means that we can act on not only data sets that fit in memory in something like pandas, as Jamie was talking about, but we can also operate on big data sets, like the classical big data sets, meaning that we can take like an arbitrarily sized Spark or Dask or Modin data frame. We can take these distributed compute data frames of arbitrary size, and we can generate the profiles on them. But here's the like even cooler thing. So we have our raw data frame that can be like billions or even like trillions of rows spread out across multiple computers, doesn't even fit in memory on a single machine. Okay, but now the profiles that we generate on them, they are orders of magnitude smaller, And importantly, they're not linearly correlated with the size of the data frame that is being profiled. To get one level deeper, they're correlated with the amount of information entropy in that data frame. So if I have a super massive data set, but it's got a lot of repetition in it, then I can generate, an absolutely tiny profile. But what we've seen working, with real data sets from massive users is that even for really diverse, really large data sets in Spark or in Ray, we still are generating profiles on the order of like hundreds of megabytes, so not even getting into gigabytes.
I have an example here I can even show. It's, a lot of the size of the profiles that we generate is related to the Apache data sketches algorithms, and they tend to be something that grows logarithmically or are bounded. If your number of features isn't unbounded, then I think that's the key. Is like for each feature that you have or each column in your data set, we generate some statistics on it. So the thing that you'll see change the size of the profiles is more the number of features than the size of the input. I was just looking at some of this last benchmark data I ran, and on a 10 gigabyte of inputs, roughly 10 gigabytes, we generated, let's see, I can actually share it if you want. All right. It's 376,000 bytes, so 300K, less than a megabyte. And on the 10 gigabyte case, it's just a little bit bigger at 386,000 bytes, so 3.800K, so still under a megabyte. A third of a megabyte either way is kind of like my brain roughly rounds it to. We can probably benefit from publishing some of those statistics about how like this relates input size to output size, but it looks good.
Awesome.
So
and Michael said, thanks for sharing the example. And then we have one more section before we'll just have open Q&A, which will be Ray demoing WhyLabs. So we've been talking about whylogs so far. We're going to take a quick look at WhyLabs.
Yeah, often a very common source of confusion between whylogs and WhyLabs. But first, big thank you to Sage, Jamie, Danny, and Alyssa for walking through all the awesome improvements that have been packed into whylogs v1. So whylogs offers a solution to profile data sets in a way that is efficient, customizable, and mergeable. We have a few new features that allow you to get some value right out of the box with constraints and performing some visualization, doing some exploratory data analysis. But these profiles pack a lot of information about your data set. And this information is sufficient to answer the most common questions that ML practitioners face on a day-to-day basis. But how do we actually go about getting the most out of these profiles? Well, if we think about what kind of things we'd want in a system for doing this, we'd want a system that first and foremost can do automatic anomaly detection. So if there's something abnormal happening in one of these metrics we track, whether it be number of missing values, schema, or the distributions, we want to be able to automatically catch those issues. We also, it would be great if we could have, when these issues are caught, it would be great if we had, if we were able to automatically receive notifications about this through common tools such as Slack or PagerDuty. And we certainly want the ability to visualize these profiles in a variety of ways that allows us to do the troubleshooting and root cause analysis that is required after we run into one of these issues. And of course, lastly, we want a system that is customizable, so we can obtain the ideal signal to noise ratio for our needs and set up a solution that works best for the way that our data behaves for a particular use case. So what we're looking at here is the WhyLabs AI Observatory. This is our platform that is specifically built to get 100% of the value out of these profiles that are generated with the open source whylogs library. So whylogs is the library to generate profiles and do the awesome things that you saw up until now. WhyLabs is the platform to get all of this value out of those. So what we're looking at here is each of these tiles represents a machine learning model or maybe a specific data set which someone is monitoring. You would use whylogs, the whylogs API, to upload the profiles that you generate from your data to one of these models, and perform your monitoring over time. So if we look up here, we see that we track for different things, including data quality, which includes things like missing values, schema changes, maybe changes in the number of unique values, and data drift, which really focuses on the distribution of your data. But on top of that, we monitor performance. We automatically build various visualizations of common performance metrics that machine learning engineers track, and ingestion alerts to notify you if your WhyLabs model stopped receiving profiles. So if I one more thing to note, we see a lot of alerts here. Just want to note that this is a data set that we synthetically inject a bunch of anomalies into for demo purposes. In practice, we would be able to fine tune the signal to noise ratio to meet your needs. If I go into one of these models, I see this view. Let me zoom in a little bit for visibility. On this left column, we see each of the features that are being tracked for my data set. For any given feature, we're looking at a summary of alerts. For data type, total number of rows, the fraction of missing values, distribution distance, the unique value ratio, and more. I do want to point out some things about this distribution distance, which is probably the most interesting one here, in my opinion, at least. Distribution distance is we quantify how different two distributions are using what's called a Hellinger distance. So for instance, if I'm looking at the distribution for this particular feature today, I could take that distribution and compare it to whatever my baseline distribution is and come up with an actual number describing how different they are. And this baseline that I'm comparing to is also something that's customizable directly within this platform, which I'll go into shortly. Whenever we see these red plots, this indicates that there is an alert associated with that. I'm going to jump into one of these features, see how we could drill down further into these alerts. So this feature I'm looking at right here, I see this first widget shows various stats describing my distribution. You can see min, max, median, upper and lower quantiles, and also a distribution distance. We could see that on May 11th, something happened that caused my distribution to become very, very narrow. And when my distribution becomes narrow, we see this spike in this blue line, which is our distribution distance, and we see an alert generated. And we talked about what am I actually comparing my incoming distributions to when I say that the distribution is different all of a sudden? Well, in this case, by editing the monitor settings, I could see that in this case, we're comparing against a 7-day window using a learned threshold. And what this means is I'm taking the distribution coming in today, and these past 7 days of profiles that have been uploaded, we're using this awesome property of mergeability to merge these together to come up with a representative profile of the last 7 days of data, and comparing that against that merged historical profile. And we're also using learned threshold, which means we have thresholds that learn from patterns in your data. So you might have one data set that behaves very differently than another. These learned thresholds can adapt to what's normal in your data set to better produce these alerts and minimize a high or low signal to noise ratio. But of course, users can set manual thresholds instead and customize further. We also, looking at a few of these other visualizations, we could look at individual descriptive stats. Missing values, it looks like this is an excellent feature with no missing values anywhere. But we do have another strange thing happening in the estimated unique values. Looks like on May 11th, we went from having several thousand unique values to only having 2, which triggered this alert. So now we know an issue has occurred. We see an anomaly. We want to dig down further. We want to do some root cause analysis. We want to see exactly what happened when it happened. Right from this view, I could take a shortcut into the profile comparison view. And in here, this view allows me to actually compare a few profiles directly. So what I'm looking at here is I'm looking at the profile from the day that had the anomaly. And by default, we throw in profiles from the previous 2 days. So just to add a little more context of what I'm comparing here, this model is set to compare data at a daily level. So in the example that Danny was mentioning before, if I have a distributed pipeline and I have profiles being uploaded from 10 different nodes on May 10th, WhyLabs will automatically merge those together, and so anything that comes in for May 10th will be merged into a single day level view. But as was mentioned, WhyLabs can also automatically do this. We can merge your incoming profiles at an hourly level, at the daily level, monthly level, whatever is needed for the use case. I could dig in a bit further into these profiles. I could see this these overlaid histograms. I could toggle these on and off to customize my view, zoom in, see more closely what's going on. We have box plots for you to compare profile against profile, and we also have these frequent items listed for each one. And let me just show, this is also, we also have this available for discrete features. And in this case, seeing actual counts of individual items could be very useful here. And one thing I do want to stress is these visualizations are not built from your actual data. These visualizations are built from the profiles themselves. So customer data never leaves your environment. It's only the profiles that collect all this telemetry that make it to the platform. So we're not building this from data. In the case of, if we look at this, the whylogs profiles have the information needed to say, okay, my bin edge is going to be negative 86. The max edge is going to be negative 58, and I have a count of 1256 in this bin. So it has the minimum information to build these visualizations, but these visualizations are really what you need in order to identify where the problem is. And if you need to go into your data to troubleshoot further, you already cut out a lot of time because now you know exactly where to look. So another thing I want to point out. So another thing that we could track is performance. So for this model, this is an example of a classification model. And we also have support for regression models as well. But for a classification model, we typically have some actuals and predictions, as well as often a confidence score. By just logging this information, WhyLabs will automatically generate some of the most common metrics that we want to track for such models. You can see accuracy, ROC, precision recall, confusion matrix, as well as others. And again, this isn't using the actual. We're not storing all of these predictions, all of these actuals. WhyLogs just generates the telemetric data needed to generate these visualizations for you. One last thing I want to jump into. As I mentioned, it would be extremely useful if we had an integration that allows us to get notifications from these for these anomalies as they happen. And it's as simple as setting up an email to deliver notifications to. We integrate with Slack. You could set up a Slack webhook to get a digest of your alerts, or even PagerDuty or more. Oh, actually, I stopped sharing. Let me share one more time, because there's one more thing that I want to say. So WhyLabs does have an enterprise offering, but anyone here could get started monitoring your first model in WhyLabs. Just going to whylabs.ai/free and sign up. No credit card needed. You could start playing around the platform and see the value that it brings for you and how it helps you to monitor your models.
And there's a demo data set already in there if you want to just quickly explore the platform and see how it measures. But you can also bring in your own data set very quickly using whylogs. There's one question. Andy might have answered it in the chat, but it's is Hellinger distance the only distance metric in WhyLabs?
So I think Andy gave most of the answer to it, but I also wanted to ask Daryl if you have like another particular metric that you're interested in using for this drift analysis, please like reach out to me. I'm trying to figure out how we want to update that and figure out what metrics we want to be tracking and allowing people to pick between, because we know that there are people with strong opinions on this.
Cool. And that was the end of kind of all the different demos. I know we're open for Q&A, and I think there might be one more slide to share somewhere that talks about one of my favorite things, swag.
Will you show Wybot a little bit more? What you got?
This is Wybot, which is one of our little mascots. And I think I'm going to share your screen.
Yeah. Well, if you'd like your very own Wybot, you can actually win one very easily from this conversation. If you share the WhyLogs V1 announcement blog post on LinkedIn or Twitter, which you can find at this link, bit.ly/WhyLogs learn more, or by just going to the whylabs.ai website, navigating to our blog, whylabs.ai/blog. If you can share this link on LinkedIn or on Twitter, or preferably on both. And then if you join the R², the Robust and Responsible AI Community Slack, and send me a message, then I will very happily ship you maybe a t-shirt, maybe this very attractive Wybot, maybe a nice WhyLabs mug. And in order to join that Slack channel, just go to bit.ly/r²RSQRD-Slack. This link also appears in our GitHub and in the WhyLogs page on the WhyLabs website. So plenty of other places to find this link to our Slack as well.
It's also in the description. So you can go right in the live stream description, as well as the V1 blog post is also in there as well. So all the things you need to get this amazing Wybot or one of these other swag items are in the description. and this t-shirt, which is very soft and nice too. Does anyone have any other questions? It could be about swag, but it could also be about WhyLogs or WhyLabs or anything else we talked about. I'm really excited for all the stuff in V1, and then I know we talked about coming soon to the auto generation of constraints is really exciting.
I'm with Jamie on the performance improvements being my favorite. Pretty mind-blowing numbers.
Such a big difference in numbers.
I love the viz. I think makes it very, very easy to explore what whylogs is collecting and customize. Really speeds up a lot of the EDA steps along with the perf. I mean, if you can profile 1 million rows approximately per second, that's a distributed right across a handful of instances, right, Jamie? That benchmark.
Yeah, the benchmarks we did, I had a resizable cluster, but I did it with using between like 8 and 20 C5 2x larges. So you're getting into the hundreds of independent processes parallel processing that. So it kind of shows the value of having it cheap to merge. And we process the data per column. Since most of our metrics are specific to a column anyway, it kind of worked out nicely. It's pretty easy to parallelize.
So
and that's in Python, just to throw that out there. Like, I mean, it's kind of cheating because a lot of the harder computation is in C++ in the data sketches library. But yeah, this is just PySpark. The benchmarks are from no Java, so you just pip install whylogs, and it worked on a number of different runtimes in Databricks at least.
Awesome. There's a question. Someone asks, can they generate profiles from any other tools that work with WhyLabs? So if they wanted to generate their own profile and bring it into the AI observatory store.
Yeah, Andy's question.
That is a
great
question. I was going to say,
Andy's already answered it.
Currently, I think there are a handful of translation challenges that we might encounter. At first, the distribution has to be in a certain shape because we really take advantage of a non-parametric distribution to monitor the drift. But that being said, we'd love to hear what tools you'd want to use to bring profiles into WhyLabs, and feature requests are very, very welcome. Yeah, so Michael, if you have any specific tools, feel free to list them here or send them to us. We'd definitely investigate and put them on our roadmap.
Yeah, feel free to put it in the chat, or if you join the Slack channel, you can message it in there as well. Any other questions from anyone in the audience? I know it's getting close to lunchtime, at least in the Pacific Northwest, so I think people are excited for lunch, maybe. They said no tools come to mind right now.
And importantly, Michael also said, I don't see why anyone would use anything other than whylogs.
I love it.
Yeah, whylogs is pretty great.
Like I was saying earlier, it's a really, really massive community effort. So Michael, really, your words mean a lot to not just the people on the screen, but to a greater community who's been very generous with their time to give us feedback as we were stumbling through the many, many, many iterations of the library before it got to this shape. And we continue thriving on feedback. So if you find anything that could make whylogs better, please let us know.
Awesome. Well, if there's no not any more questions, I think we could go ahead and probably end our stream, unless any other questions come in right at the last moment. If not, make sure to stay connected with us in the Slack channel. You can check out whylogs v1 README. Everything else we talked about, the links are in the description. So if there's any other questions, though, after the stream, definitely stay connected and let us know. And thank you, everyone who came out, and thank you again to everyone on the screen who took the time to present all these awesome demos. Cool. People are saying thank you in the chat. Thank you again, everyone, and hopefully I'll talk to some of y'all later.
Thank you all.